Your legacy EMR has the only usable copy of a longitudinal chart, no FHIR endpoint, and a decade of clinically important data trapped behind menus. So the question is not whether an agent can click through it, but whether you can use that capability without mistaking a temporary bridge for clinical architecture or allowing it to mutate the original record. You will learn 3 things. First, browser use means an agent interacts with a web interface through its structured accessibility elements. Computer use drives a desktop application when no web interface exists. Second, can extract legacy system information, but neither makes it interoperable. Third, a clinical implementation should be read-only, evidence-producing, and scheduled for retirement. As soon as a real source integration ships, browser automation lets Hermes navigate a web application, read the page structure, click an identified control, enter text, and capture a result. It is useful when a system was designed for human users, rather than for an application programming interface. Instead of an API returning a patient's structured observations, the agent may have to open the chart, choose a date range, and read a results table. Computer use extends that idea to a desktop application. It can see a controlled window, interact through accessibility elements, and perform clicks or typing. Browser use is preferable whenever possible because it can run in a bounded browser session. Computer use has a larger capability surface and therefore a larger failure surface. It can encounter native dialogues, desktop notifications, pasted clipboard data, or an accidental focus change. Neither primitive understands medicine. They are interaction mechanisms. They can move through interfaces that text-only tools cannot reach, but they inherit every weakness of the interface: changing labels, pop-up alerts, session timeouts, inconsistent chart layouts, hidden pagination, and data that appears only after a human clicks through 3 screens. For a practice with a legacy EMR, the legitimate use is transitional extraction. The target architecture remains clear. Hermes is the nervous system that coordinates work. A FHIR-canonical clinical data platform is the memory and source for downstream workflows. The legacy EMR is a temporary upstream source while the practice builds or purchases a supported integration. Browser use is the narrow pipe between them, not a replacement for either system. The narrowest safe implementation begins with a dedicated legacy EMR service account. It has read-only permissions, access only to the selected patient cohort or export workspace, no access to billing administration, no ability to prescribe, no ability to sign notes, and no permission to modify demographics. The execution environment is isolated: a managed browser or virtual desktop, separate credentials, session logging, encrypted temporary storage, and no personal browser profile. The agent also needs a precise extraction specification. Read the chart is not a specification. A safer request is, for this physician-approved patient list, retrieve the signed encounter note dates, active medication entries, laboratory observations with collection date and unit, imaging report text, and document provenance, export to the approved staging location. Do not infer missing fields. Do not alter any screen. The output schema defines what success means. It also needs an accountable data steward who can stop it when quality drifts and monitor it continuously for subtle mapping errors over time carefully. The rule is, browser or computer use may read a legacy system and stage a provenance-preserving export. It may never write back into the EMR. Every run uses a dedicated read-only account, an isolated environment, a defined schema, and a stop on ambiguity policy. Human review validates exceptions and samples before A. Separately governed import commits data to the canonical platform. No browser agent. Signs, orders, reconciles medications, closes a result, sends a message, or modifies. A chart. If the UI changes, identity cannot be confirmed. A. Source field is missing. or validation fails, the agent stops and hands the item to a human. A bridge should fail visibly, not work creatively. This week, identify one legacy screen that your staff repeatedly reads by hand. Do not automate it. In under an hour, write its extraction contract, the exact fields needed, the source location for each field, the meaning of missing data, the required provenance, the human validation, sample, and the action that must never occur. Then add a sunset. Condition: what supported export or API must exist before this bridge is retired. If you are already using robotic process automation, inspect one run for its evidence trail. Can you tell which UI version it saw, which records failed, what it extracted, and who reviewed the exception? If not, do not broaden the workflow. Improve observability and reduce scope first. A legacy bridge is sometimes the responsible transitional choice in daily care. The irresponsible choice is allowing it to become a silent, write-capable substitute for a validated clinical data platform. This video is for educational purposes only and does not constitute medical advice or legal advice. Any implementation of AI agents in a clinical setting must be reviewed against your local HIPAA posture, state board requirements, malpractice carrier policy, and your own professional judgment. The physician remains the accountable clinical decision maker.